So hello everyone, I'm Hannah. I currently work as a sales manager at HCM Taiwan. So it's my honor to take part in this conference. Yeah, so, this is, by the way, this is the SEM of our LMFP. So today in my presentation, I will talk about who we are and also share the up-to-date data about our LMFP material and also the cell, and including our equipment technology. And last, I will talk about our business strategy. So actually, unlike other material makers, our company actually started from the powder equipment, such as the spray dryer and also the sand mill. So with the equipment background, we started to develop both LFP and LMFP in 2010. However, at that time, we noticed the market of LFP was so mature that at least hundreds of companies were working on that. Conversely, seeing the potential of LMFP, we decided to focus on this material only and successfully turn LMFP into mass production in 2016. So we further leverage our strength in equipment and material to offer the turnkey service. So this is the case. We work with a government-owned Taiwanese gasoline company. So we help them to set up the production line with an annual capacity of 1,000 tons for LTO, the annual material. So you can see that the clip there, this is the clip of the spray dryer being installed at their plant this May, I guess. So starting from this year, we will focus on developing the strategic partnership, which will be elaborated in the business strategy part. So this is the roadmap of our LMFP product. We've been optimizing this material since 13 years ago. So you can see that right now, So you can see that right now Gen 1 and Gen 2 are already discontinued. And right now G3 is mostly widely adopted by our partner. And in order to optimize the processability of our material, our team right now is developing so-called Gen 4. And in the future, we will be focusing on the tailor-made LMFP, such as we can customize the particle size or the manganese or iron ratio for the partners. So here's the half-cell testing data of our material. Our material has a specific capacity of 150 milliamp hour per gram. So you can see that the power capability is very superior. And the specific surface area is about 12 meters square per gram. And the maximum press density is 2.3 gram per cc. And you can also see that the carbon loading is very low, so you can fully utilize the capacity of the material. So we have successfully developed the power type LMFP cell. They shows the high rate discharge capability at 12C and exceptional cycle life over 5,000 cycles. Besides that, by blending soft carbon and graphite, you can see that the cell can be charged at high rate at 3C charge and discharge and retained about 85% of the capacity after 4,000 cycles. And we also successfully developed the so-called energy type LMFP cell with a single side electrode loading of 4.5 milliamp hour per centimeter square. So with this loading, the thickness of the electrode was about 240 micron before calendaring. So you can see that the electrode density was about 2.2 gram per cc. And so the cell also has the energy density of like 185 watt per kilogram. So you can see that the cell actually retained about 75% of the capacity after 5,000 cycles at 0.5C charge and 1C discharge at room temperature. And it also retained about 72% of the capacity after 818 cycles at 45 degrees C. However, after 5,000 cycles, we noticed the discharge curve of the cell revealed the disappearance of iron plateau. Therefore, to investigate the capacity fading mechanism, we disassembled the cell and took out the positive and negative electrode to conduct the so-called half cell formation. So during the process, we observed the appearance of iron plateau, and the capacity of the material returned to over 95%. So actually, this indicated that the disappearance of iron plateau was due to the lithium depletion. So this means that maybe in the future, we may be recycle the LMFP by replenishing lithium to the material. Okay, so in addition, the ICP analysis of the anode electrode also shows the presence of 310 ppm manganese in the graphite anode. Okay, so to have a better understanding of thermal stability of LMFP, we also carry out the nail penetration test on both pure LMFP cell and also LMFP with NMC, so-called the composite cell, in which a regular PP or PE separator without ceramic coating was used. So you can see that actually the LMFP cell passed the safety test with the maximum temperature about 78 degrees C. Right here. And we also have the 60% of LMFP with 40% of NMC-A11 composite cell, which achieve an energy density about 215 watt-hour per kilogram. So you can see that this cell also passed the nail penetration test with the maximum temperature of 90 degrees C. Okay, so let's turn our attention to the impact on the electrostructure, on the electrochemical performance of the cell. So in addition to studying the composite cell, we also examine the dual layer cell with either NMC or LMFP in the top layer, just like the HCM shows here. So you can see that actually the dual layer cell with the NMC in the top layer, which is marked in blue, actually had the best discharge power capability. Conversely, you can see that the dual layer cell with LMFP in the top layer had the best charge power capability. So among these cells, we also observed that the dual layer cell with NMC in the top layer, which is the blue part, actually had the best cycle life performance. So in line with the aforementioned LMFP-rich composite cell, we also noticed the similar trend in so-called the NMC-rich composite cell. So this one had 70% of NMC with 30% LMFP. Among these cells, you can see that the dual layer cell with LMFP in the bottom layer had the best charge and discharge power capability, surpassing the so-called the composite cell and the cell with the LMFP in the top layer. And we also successfully developed the 80% of NMC with 20% of LMFP composite cell, which achieve an energy density of 225 watt-hour per kilogram. However, when using a regular PP or PE separator, without ceramic coating, we noticed that the cell did not meet the safety requirement. So we were thinking if there's other alternative measure to enhance the safety of the cell. So we were thinking to use a ceramic coated separator. So with that, actually, the NMC composite cell with 30% of LMFP and 50% of LMFP, they all passed the safety test by using the ceramic coated separator. So we also have the 4 amp-hour dual layer lithium metal cell with LMFP in the top layer. So the cell achieved an energy density of 352 watt-hour per kilogram and retained about 80% of capacity after 400 cycles. So the cell charged to 4.1 volts actually passed the safety test and also the overcharge test to up to 19 volts. So this is the contents for our LMFP material and also the cell. So I'll move on to the next part. So in order to fabricate the high quality LMFP, actually equipment plays a very important role. So most of the equipment here are actually designed and integrated by our team. So this time I will just focus on the spray dryer, furnace, and smart manufacturing center. And during the spray drying process, our goal is to produce the ultra-fine powder to make the material a better performance. So our team developed the so-called new typed nozzle that can easily achieve the goal like this. And also with the unique flow design, it can help reduce the chamber size and the utility cost by 50%. And speaking of furnace, right now we are working with a Japanese furnace maker to develop the furnace with a multi-layer stagger design. So with this design, it can improve the space issues and also maximize the production capacity. Furthermore, our team also leverages the integration capability to build up so-called the smart manufacturing center. So actually, the staff can stay at the office to monitor the real-time data and the status of the production. So by this way, it can further optimize the production quality and also minimize the labor cost by 50%. So our current production capacity right now is 1,000 tons per year, and which is the gray part here. And starting from last year, we've been setting up the other so-called the demo line, which is marked in blue here. So we are now moduling the production line. So in the future, we can easily scale up the capacity by duplicating the demo line here. And you can see that in the center of our plants, we are also setting up the government-funded battery manufacturing pilot line. So it's scheduled to be ready by next year. So this line can produce about 5 to 20 mAh pouch cells for sampling purpose. And it will help our partners on the battery evaluation and accelerate the commercialization of LMFP cell. So right now we work with the Tier 1 makers to apply our material in different applications, including the EV, ESS, and eVTOL. And you can see that most of them are in the US, Europe, and also Japan. So, so I would like to talk about my ideas about the business strategy. So as you know, we are the LMFP makers, so it is no problem for our company to supply the material to your country from Taiwan. Second, our equipment can be used to produce not only LMFP, but also various materials, including LTO. So for the partners who already have the material technology, we can supply the tailor-made equipment for their production. And if they are looking for scaling up the production line, then we can just help them to do the turnkey service and help them with the equipment integration. And third, now, as you know, many companies are trying to integrate the supply chain and trying to produce the material locally. So, however, many of our partners are from cell makers or car makers, so they do not have much experience in material production. So we can use our strength in material and equipment to collaborate with them. So for example, we can set up the joint venture company that HCM help them with the material production, and while our partner will be responsible for the market distribution. Besides that, we are also very open to any possible options, such as like the material co-development or the direct investment. So to sum up, we are the only LMFP maker that has a very solid equipment background and experience in LMFP mass production. So as you know, this market is growing and we believe LMFP will be the future trend. So our next goal is to set up a plan overseas to get closer to our market and partners. So right now we're preparing everything possible, and I hope that we can meet you in Europe soon. So, well, this is the end of my presentation, and our chief technical advisor, Dr. Liao, he will also join at Q&A session. So if you are interested in learning more about LMFP technology, feel free to exchange your feedback with him. So thank you very much.